This video is a continuation of my previous video about cargo hold capacity calculations, where the voyage instruction is to load 30,000 metric tons of coal, plus or minus 10%, more or less owner's option, and the cargo stowage factor is 1.40 cubic meters per metric ton. Both the loading and discharging ports have no draft restrictions, and are in salt water with a density of 1.025. Additionally, the entire voyage falls within the summer load line zone. The previous video shows how to calculate the maximum loadable cargo, the total capacity of all 5 cargo holds, and the individual capacity of each hold, from hold number 1 to hold number 5. If you want to watch the part 1 of this series of video, kindly check the link in the description. In today's video, we'll work with the same voyage instructions, but with a change in the discharging port. The discharging port now has a draft restriction of 10.00 meters, and a water density of 1.018. The loading port remains unchanged, with no draft restriction, and in saltwater, with a relative density of 1.025. Additionally, the loading port is located in the summer zone, while the discharging port falls within the winter zone. Since there's a draft restriction at our discharging port, we'll start our calculations from this port, a method often referred to as loading back. We also need to account for the load line restriction, as the discharging port is located in the winter zone. Let's check the ship's winter draft, as this represents the allowable draft and the ship is floating in saltwater within the winter zone. Comparing it to the required draft at the discharging port, we see that this draft is lower, so this draft will be our main concern, because when a ship moves from water with higher density to water with lower density, her draft increases. This means that while the ship is still in saltwater before arriving at the discharging port, her draft will be slightly less than 10.00 meters. If you are not familiar with the change in ship's draft due to the change in water density, I have made a separate video about this. Kindly check the link in the description. Considering all consumables and fuel consumption when the ship sails from summer to winter zones, we can say that as long as we meet the required draft upon arrival, we will also comply with load line restrictions. Now, let's start by calculating the maximum cargo we can load based on the draft restriction at the discharging port, allowing us to distribute this cargo across the ship's 5 cargo holds. First, coordinate with the chief engineer on board for the remaining fuel upon arrival at the discharging port. Let's assume that these are the ROBs given for the fuel oil, diesel oil, and lubricating oil. For the unpumped ballast and fresh water, we can determine it through sounding, and by using the ship's sounding table. Assuming that the ship's constant is 117 metric tons. The total deductibles or non-cargoes upon arrival at the discharging port is 690.30 metric tons. Now use the ship's hydrostatic table, and extract the corresponding ship's displacement at a draft of 10.00 meters. Assuming that the ship's displacement at a draft of 10.00 meters is 37,518 metric tons. Take note that this hydrostatic table was developed when the ship was floating in salt water at a relative density of 1.025. Then subtract the lightship or lightweight from the displacement, to determine the deadweight. Lightship can be found in the ship's general particulars. Next, subtract the total deductibles from the deadweight, to determine the loadable cargo. This loadable cargo is when the ship is floating at a draft of 10.00 meters in saltwater, with a relative density 1.025, because the displacement extracted from the hydrostatic table is in saltwater. To determine the maximum loadable cargo at a draft of 10.00 meters, upon arrival in the discharging port, with a dock water relative density 1.018, we will apply the density correction. The formula is, density correction is equal to, displacement in saltwater at a draft of 10.00 meters, multiplied by the difference in the relative density of saltwater, and the relative density of the water in the discharging port, divided by the relative density of salt water. The density correction is 256.22 metric tons. By subtracting the density correction, the difference is the maximum cargo that we can load in our loading port, so that when we arrive at the discharging port, our arrival draft is 10.00 meters. Now you might be thinking why the density correction was subtracted, not added. Remember that this loadable cargo is when the ship is in saltwater at a draft of 10.00 meters. Before entering the port, the ship's draft should be less than 10.00 meters because, moving from water with higher density, in this case, 1.025, to water with lower density 1.018, the ship's draft slightly increases. This is the reason why we need to subtract the density correction, instead of adding it. In my previous video, we calculated the maximum cargo that a ship can load, but in this scenario, due to draft restrictions in the discharging port, and also due to load line restrictions, our ship can load lesser cargo. This is supposed to be the cargo that a ship can load to each hold with no draft restrictions, with a total of 28,802.22 metric tons. Due to draft restrictions, we can only load 27,057.48 metric tons of coal. Let's leave this maximum cargo that can be loaded for each cargo hold so that we can compare it later on with the new loadable cargo. To distribute this new loadable cargo across the ship's 5 cargo holds. First, we'll determine the volume capacity of each hold using the hold capacity plan. Here are the volumes for cargo holds 1, 2, 3, 4, and 5. The total volume is 40,323.09 metric tons. Then determine the percentage capacity of each hold, which is equal to the volume capacity of each hold, divided by the total volume capacity of all 5 holds. These are now the percentage capacity of each cargo hold. For hold number 1, 12.552%. Hold number 2, 22.237%. Hold number 3, 22.233%, so as with hold number 4. And hold number 5 is 20.745%, with a total of 100%. To determine the amount of cargo that can be loaded on each hold, multiply the total loadable cargo by the percentage capacity of each hold. So the loadable cargo for hold number 1 is 3,396.25 metric tons. For hold number 2, 6,016.77 metric tons. For hold number 3, 6,015.69 metric tons, so as with hold number 4. And for hold number 5, 5,613.07 metric tons. The total amount of loadable cargo is 27,057.47 metric tons, the same amount of loadable cargo previously calculated. If we compare the loadable cargo without draft restrictions, now the loadable cargo is reduced due to draft restrictions. To trim the ship, you can adjust the loadable cargo on hold number 1 and hold number 4 or 5. That's all for now. I hope you found this video helpful. See you next time. Thank you for watching. Bye.